All right, this week's homework, jump right in. If you hear something that sounds like a heavy metal something dropping on the floor, the discus or shot put is practicing outside of my classroom, so you can just ignore that. Just to start, it says to box the slope and circle the y-intercept. So what we've learned in class is that the number that is at the end of the equation, so all of these right here, they're going to be non-proportional because they have a y-intercept and it's not going through the origin. So our slope is this number before our x, and our y-intercept is this at the end of the equation. And this y-intercept is always plotted on the y-axis. And that's because when you substitute, if you substitute a 0 in for this right here, so y equals -2 times 0 plus 3. -2 times 0 is 0, and then we're left with a y equals 3. So your coordinate point ends up being 0, 3, and this right here would be plotted on the y-axis about right there. So just showing you that is always going to be on the y-axis, whereas this one here on the y-axis as well, except this one here is make sure you see that negative, and this one here is a 1/2 slope. And remembering that slope equals rise over run, and so remembering also that right here, if you don't see a number, we always know that 1 is invisible. So 1 invisible. All right, and make sure to answer this question here. Graph the following equation, y equals -x. So just like we did before, we have an invisible 1. There's an invisible 1 right there. So we have a y equals -1x. So again, when we're looking at slope, we have a rise over run. So right here, we have a rise, but we don't have a run. So remembering that in order to make -1 a fraction, we have to put, but we still want our value to be -1. We have to know that this number here, the only number that we could put here is a 1 in order to result in a -1 as our answer. So this one here, this equation here, y equals -x, -1x. This is a proportional graph because we don't have, there's no y-intercept, so that is going to start from the origin. And then we have to rise one, but then we need to make sure we have a negative graph. So if you remember slope man, we have puff, puff, positive, and then we have nice negative here. So our end result needs to be a line that is going in this direction like this. But so we have our y-intercept, and then we're going to have to go up 1, and then we're going to have to go over 1 this way. Or you could go down 1 and over 1. And that's because of keeping the direction the same. All right, so again, remembering that this right here is our y-intercept, and this number here is my slope. So we have a rise of 9 and a run of 5. So I'm going to start with my y-intercept. You always want to start there. So I'm going to go 1, 2, 3, 4, 5. And then since I can't go down 9, I can go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then I need to run 5. If I go to the right 5, 1, 2, 3, 4, 5, I'm going to have a line that is positive, and that's not what I want. So I'm going to make sure I go 5 negative. And then you can go ahead and connect your 2 dots like that. All right. Now we have, what is the equation of this line? So now we're kind of working backwards. They have the line. So again, we've worked with finding pretty points, so that's maybe a good place to start. So when we say y equals mx plus b, this m representing our slope and this b representing our y-intercept. So with that being said, we know that our y-intercept is always on the y-axis, so this is our y-axis. So our y-intercept is going to be equals positive 3. And then our slope, we have a rise. So slope equals rise over run. So we have 1, 2, 3, 4, 5. And we have a run of 2. And then our final line is negative. And something that, if it helps you, you can extend the other side of the line to just see, oh, okay, this right here is, this line here is positive, leaving our red line negative, so that is what our answer is going to look. So in your final, you're going to want to write your equation, y equals blank x, and then with your y-intercept. Let's go to this one. Okay, write the equation of this line. So again, we have these pretty points right here. And look, there's a lot of them. This one has a lot of pretty points. I know that the graphs on your paper are sometimes more faded. So again, we're going to be looking for our y-axis, our y-intercept. So our y-intercept right here is going to be at negative 4. And then our slope is a rise of 1, run 1. So simplifying that into a y equals blank x with your y-intercept. And here it says use the following table to write an equation in slope-intercept form. So slope-intercept form, if you forgot, is y equals mx plus b, with the slope being here and the y-intercept being here. So there's multiple ways you could go about doing this. I'm going to first find the slope by using 2 coordinate points, remembering that these are actually negative 4, and 0, 1, and 4, 6. So remembering that my slope formula, y equals y2 minus y1 over x2 minus x1. So I'm going to label, I'm going to erase this, x1 and y1, x2, y2. So when I substitute these in, I have y2 is 1, draw my line, subtraction sign, 1 minus negative 4 over x2, which is 0, minus negative 4. So 1 minus negative 4, so remember 1 minus negative 4, that would be 1 plus 4, which is 5, over 0 minus a negative 4, so 0 plus 4, 5 over 4. So this is equaling our m, which is our slope, either one is right there. So now we have y equals mx, which is 5 over 4x, and then we need to figure out our y-intercept. So in order to do that, in this instance, we have this given to us right here, 0, 1. So if you were to plot this point right here, you would start at the origin and then you would go up 1. And since that's on your y-axis, this is actually going to be your y-intercept. So y equals y-intercept, so a positive 1. So then you can add that into your equation there. Use this equation to substitute the following x values to find what the value of y would be. Okay, so for this first one, we're substituting x values. So we have y equals 1/3 times 0 plus 5. So 1/3 times 0, any number times 0 is 0. So that means we're going to have y equals 5 right there. So then if we substitute 3, we're going to have y equals 1/3 times 3 plus 5. So 1/3 times 3 is going to be 1. 1/3 times 3, if you think of like a third of a pie, if you take only a third and you multiply that 1/3 times 3, that would give you a whole, which would just be 1. Y equals 1 plus 5, which is 1 plus 5 is 6. And then we have y equals 1/3 times 6 plus 5. So 1/3 times 6. So if 1/3 times 3 was 1, 1/3 times 6 is going to be 2 plus 5. 7. And then the last one, I'll let you do by yourself. 1/3 times 9 plus 5. And that will give you what will go there. So then I'm going to make it a little smaller just so we can see. It says graph the points above and what is the slope and what is the y-intercept. So we have, remember, this is written 0, 5. This is written 3, 6. This is written 6, 7. And then 9 and whatever you found there. So if we have 0 over 0 up 1, 2, 3, 4, 5, that's our first point. And the next one is 1, 2, 3 over 3 up 1, 2, 3, 4, 5, 6. And I'm sorry, I didn't make the graph big enough to, maybe if this was 7, extend our graph a little bit. But if you just plot the, so that would be over 6 up 7 would be there. And then that's probably enough to be able to graph your points. And that will give us a nice little line. And so again, what is the slope? So we can use our graph to go rise. Our rise is 1 and our run is, you can figure what that is. So our rise is 1 and our run getting to that next point. And then our y-intercept, remembering that our y-intercept is on the y-axis, so whatever that number is there. Okay, when can you use k to describe slope? When can you use k to describe slope? So we have, if you remember, y equals kx, where k is the constant of proportionality. So that kind of answers your question. K can only be used when the relationship is constant. So this right here, it can only be used when you have something going through the origin, when you have a proportional relationship. If your graph does not go through the origin, that is, this would not be a time that you would want to use k. So this is where you would have a k, whereas here, this right here, this would be an m. And then going down here, it says, in your own words, write what the vertical line test is. So I guess if I were to draw a graph, and I drew a graph weird like this, what would you be able to use in order to tell what does the vertical line test tell you? How does it help you determine something? The drawing illustrates A. Okay, so this is a little bit of a review question. So if we have, so I have a little P right here. All right, and we're looking for what type of transformation. So we're doing a transformation. So if it was a rotation, I would have to rotate it to get this same one. But if you look, as I just slide this down, so what is the transformation type in the answer choices that talks about a slide? What is the other word for a slide? And the bottom portion are two questions relating to the star. Which situation represents a proportional relationship? So we're looking for a proportional relationship, which, if we remember from up here, that's going to be an equation that's going to be written y equals kx. So we're looking for something that would go through the origin, some relationship that if you bought 0 things, you would go, if you worked 0 hours, you get $0, or if you sold 0 candy bars, you would earn $0. If you walked for 0 minutes, you would walk 0 miles. So the cost of purchasing a basket of oranges for $1.30 per pound plus $5 for the basket. So if we're thinking about this, we have $1.30 per pound. So that means this is going to be our per is our variable. So if we remember from the beginning, we always boxed our variables and we circled our constants. So that's going to have a constant and a variable. Whereas this one only has a variable. This one only has a variable. So that is not correct. The cost of purchasing peaches for $7 per box. So we have $7 per box with a delivery charge of $3. So even if I don't buy any boxes, I'm going to get a delivery charge of $3. So once again, we have that additional, so this is going to look like y equals 1.3x plus 5. This one's going to look like y equals 7x plus 3. So these ones are not in the form of y equals kx. So these are y equals mx plus b, which is a non-proportional. So you can go ahead and look through the other two to see whether that would be a proportional or not. Okay, the value of y varies directly with x. When y equals 75, x equals 1/2. What is the value when x equals 2 1/4? So, our green light here, the value of y varies directly with x. This is our green light to set up a proportion, meaning it's a proportional relationship. So, again, we have y over x. So we have when 75 is y, x is 1/2. When y is, we don't know, x is 2 1/4. So then you can cross multiply and divide, or you could use y equals kx to solve for k, our variable. So you could substitute 75 equals k times 1/2. So then I would divide both sides by 1/2, and then 75 times 1/2 will give you what k is. So k equals 75. $75 divided by 1/2 will give us k as 150. So 150 is our k, and then we can set up our equation. So we're looking for y. So y equals, now we know k equals 150, and we know x is 2 1/4. So either way, you'll be able to get your answer. So whether you use this way or this way, you'll get the same answer, and hopefully this is helpful.